1.
Weil es leuchtet grün. Man sieht, dass es an ist.
Test.
Test.
Okay. So, hello everybody. 1 o'clock. We are back again. We hope you too. Welcome back to the second part of our CO2 training. As I said before, we will do the commissioning of our rack system. Today I have the pleasure to introduce you my colleague Sergio Stofba. He's one of our sales managers. Normally they are not in the house, they are all over the world. He's today here, and I just want to use the chance and to introduce him, but he can do it by himself.
Thank you, Michael. Hello everybody. Thank you very much for the participation of our training. I hope that you really got and will get interesting information. And as Michael said, I am a sales manager and team leader of the East European countries. And today we want to make some special offer to you, because we saw that it's a lot of customers also from Belarus, Russia, Ukraine. And we would like to offer you, if you like, on the end of the seminar, after we will have discussions with English-speaking customers, and we can answer all questions what we will get in English. We can spend 15-20 minutes more, and if somebody doesn't trust himself to put questions in English language, I will be here again, and we can drive some discussion in the Russian language. I hope it will be really helpful for you and for us, maybe to give you as much as possible information of the seminar.
Can you give us a short sentence in Russian language?
Коллеги из русскоговорящих стран, Беларусь, Украина, Россия, приветствую вас еще раз. Большое спасибо за то, что вы принимаете участие в этом семинаре. Надеюсь, что действительно информация была полезной и будет полезной. И сегодня мы хотели предложить для тех, кто, может быть, не совсем хорошо владеет английским языком, но у кого есть какие-то вопросы относительно семинара, относительно продуктов, относительно установки, относительно темы CO2, в конце семинара, после окончания дискуссии на английском языке, я снова приду сюда в студию, и вы сможете задать ваши вопросы на русском, и я либо постараюсь ответить напрямую, либо я постараюсь перевести и получить ответ от коллег. Поэтому, если эта опция интересна, напишите, может быть, или поставьте какой-то значок, палец вверх, и тогда мы будем знать, что будут вопросы, и я снова буду в студии. Большое спасибо, и ждем вашей реакции.
Okay, I couldn't have done it better.
Thank you.
Thank you, Sergio.
See you later.
So we will see him later then at the end. Thank you. See you later. We need a microphone. Yeah. Okay, guys, welcome back. Yes. How we will go on now? Yanni, can we first show the VIP as I promised, or shall we do it later? We will try again. In the morning, I tried to show you the VIP and it didn't work. I just want to show you that in 1-2 minutes. It's really a great program. You can find it in the internet, as I said. Here you can choose your languages. We have many languages where you can switch off and choose. Now we have it in English here. You have different ways to find a compressor. For example, the easiest way, that's what I always do, is just to go here, for example, semi-hermetic compressor, then it pops up here. You can choose what you want. We want to show CO2 compressors.
Können wir auf den rechten Bildschirm mal zugreifen? Danke.
So, for example, I will choose transcritical compressors. Then it opens up the window with all our CO2 transcritical compressors. As I said, HX12 this morning, the new one, HX24, up to the biggest one. So we can choose here one. Just switch on. And then, as I saw, yes, you can see, you can choose ML, That's a normal standard compressor. Then S is for the stronger motor. And you can choose between SH, this is when you have higher evaporating temperatures for heat pump, for example. So to see the difference, yeah, you just click on the normal one, the ML, you see everything on the first slide. And you see here, you have always, if you choose a point, a working point, you have to stay in the blue range here. You can find here also everything. You can find the technical data, dimensions and connections. You can find on that slide product photos, and also very important for you, spare lists. You can see, let's open one, a high resolution drawing, for example, where you can choose parts, or you can see what's inside the compressor here. Or you can choose spare lists. If you open that one, then you can find all the spare parts in this compressor. So really, yeah, a great program where you can find on one side, you see every important things you need here. You can change the evaporating temperature. You just put on here what you need. Gas cooler outlet. You see then the operating limits. You see here the data, what power consumptions, current draw, that is changing. For example, if you change here the data's evaporating temperature, for example. Yeah, okay. So just to show you that very fine program, please test it and you will learn a lot of things. Okay. Yes, the BOCK shop is also important. Here you can see the BOCK shop. If you click on this point here, then the BOCK shop is opening. And then you can, here, for example, you can change also the languages here. Here we have only two possibilities. If you have a serial number of or a machine number, you just write the machine number in here, and then the window pops up and you will find everything, especially to this special compressor of the machine number you typed in. You can find every part and also every data to this compressor. Okay, so far that. Shall I close it, Yanni, or you will just change? Okay, where's Frank?
Did we need him?
Yes. So, okay, we will start to show you the application. First of all, here's our rack system with the subcritical low temperature compressor. Hast du jetzt gewechselt, oder?
Ja.
Okay. First of all, yeah, the training center here in Frickenhausen that we built. Here with our rack system, like I said, the subcritical compressor for low temperature application. Here is the middle temperature compressor. And here we have our parallel compression. Then we have here our heat recovery. Here we have the ejector. Then we have the receiver on this side. And as you can see here, we have all the Danfoss frequency converters on the side. Then we have a small supermarket built here for you. Yes, of course, we have to show some cabinets when you do the training. We have a low temperature cabinet here. And we have a middle temperature cabinet, as you know it from the supermarket. And we have also, of course, because we have too much power with our rack system, outside we have also evaporators. We will show you this also now. But this outside is only for the training center. You don't need it, of course. The outside evaporators could be some additional storages in the supermarket or wherever. But we put them outside. So it's a bit cold today, so I need a jacket. So here we are outside here of our training center. I hope you can see me. Yeah, great. First, you can see here the low temperature evaporator on this side. Then we have a middle temperature evaporator that could be in a supermarket, of course, like I said, additional cabinet or a big storage room or whatever. Here we have the condenser or the so-called gas cooler with all the components. Then here we have very important, you can see the first pressure relief valve here with 120 bar in this case. Then we have the sensor, the temperature sensor. Das ist die Rückleitung, gell? It's important that if you place the temperature sensor, this is the back pipe. That's the liquid or liquid gas. How you heard it this morning in the from Knut. Goes back to the application, to the receiver. And here this is, like I said, important that you have the sensor, the temperature sensor, not directly on the gas cooler. Just give them a bit, half a meter or a meter spare place, and then put this sensor here. And you have a frequency control here as well inside. In this box, what do we have here? No big surprise. We have here the pressure relief valves of the whole system. Yes, guys. So you can see we did our pressure relief valves outside, of course. Why? In case of we have a high pressure, and in case when they're open, then all the CO2 goes, of course, outside here in the atmosphere, and it doesn't matter. It won't influence anybody who's inside, of course. That's something that's most rec builder do that. Do the piping. I'll bring the piping out of the machine room, out in the normal area, atmosphere room. And here you can see, for example, we have a 60 bar for the liquid line. Yes. Then for 45 bar for the middle temperature line, and 30 bar, it's totally enough for our low temperature side. Yeah. Yeah, that's how we did it here. Nice closed, so that nobody can do here something. And then, if you look upside, we have also, wie viel bar is there? 90. This one is a 90 bar. That's the middle pressure of the system. It's also the same. You see two of them on top of it. So if you have to make a service, you can change one. And if one of them has a problem, you can exchange them, and you don't have to let out the whole CO2 out of the application. And the next thing, a positive thing about CO2 is if you, for example, have to work on your application, on your system, and you need to put out the CO2. You just put a pipe outside. You can let the CO2 in the atmosphere. You don't have to recover it anyway. It's just it's allowed to leave it in the atmosphere, because it's one out of some procedures, out of chemical procedures, and it's no problem to let it out in the atmosphere. You don't have to fill it in the bottle like synthetic refrigerants. Okay, my colleagues are freezing. That's what we have outside here, so we can go back inside. Yes. How cold is it outside? I think 2 degrees today here in Germany or in south of Germany. Yeah. So that's, and here you can, Frank. Thank you, Frank. The electric box, it's a big one with all the Danfoss stuff inside also. Yes, all the Danfoss regulation controllers, excuse me, controllers, not regulation. Then we have the ventilation of the CO2 warning system. Here's the box of the CO2 warning system. We have a heat recovery. I said before, we produce hot water here inside during running of the system. And we have also, of course, air conditioning that we have. I don't know if you can see it. Yes, up there. This is also connected. I will show you that later. So we cool the cabinets here. We heat up water. CO2 is fantastic to get really, really hot water for production if you need whatever. And we do the air conditioning as well. Everything with this system here. Okay, so now I would say.
We had a question.
Oh, yeah, so we have questions.
Kannst du
Yeah.
nochmal wieder umschalten?
Okay. Mr. Andriy Savchuk is asking, my name is Andriy, I am design engineer in Sub-Zero Kiev, and now I'm designing a CO2 booster system with parallel compressor for a plant. As you know, the working pressure of the refrigerant is up to 120 bar, only on the discharge line. Yes, that's can be, yeah. Working pressure on the liquid and suction line are less than 45, 30 bar. So the question is the possibility of using K20 tubes instead of K65 on suction and liquid line, where working pressure allow use to do this? Well, from the
K20, I didn't know.
we have K65 here on our system.
Are we using in Germany K20? Yeah, I don't think so. It's
K20, K65, K20.
it's the possibility.
Mr. Savchuk, we're sorry, we didn't heard about K20 tubes. Maybe if you have more information, you can write it down later. We know that we can go up to, with our K65 tubes,
Up to 140.
140 bar is the maximum with K65. And that's the only that we use here. So maybe if you can get more info, we don't have the informations about K20. Here in Germany, usually, or Europe, K65.
It's normal.
It's the normal. And then, of course, it depends on the dimension. It ends on
Absolutely.
at 22 millimeters.
Yeah.
Then you have to use steel.
Stainless steel.
Stainless steel, of course, yeah. We have here, as you can see, also a part is in copper, the K65, but also discharge pipes here are in stainless steel. The discharge side, because of course we had a big eye on safety here on the training system.
We have too much money.
And we had too much money. Stainless steel is also, but the copper prices at the moment are also very high.
Yeah.
One thing to show you how you can test if you have a K65 is just you can take a magnet, yeah, and then, let's see.
Von der anderen Seite rum.
We need a camera.
Ja, man sieht dich.
Das sieht man schon.
Man sieht dich.
Yeah. Ja, von der Seite sieht man es nicht. You can see it?
Ja.
Okay. So the magnet will hold on the copper pipe, so you know you have K65. If it doesn't hold, that means if it's not holding, then you have a normal copper pipe. and it's not allowed to use that. Okay, good. Then, as a next step, I would say first, Knut, we will show you the drawing of our system, and he will explain. We will go through the whole system on the drawing. Maybe that's better than for you to get a better understanding. We have just a small problem at the moment.
we are searching the diagram. We don't know where the diagram is.
Okay.
I think just close store view and open it again.
Yeah, sorry, guys, this is live. Sometimes you get a technical problem, but we will solve that also.
No, just close noch mal. Mach mal unten die Dingsleiste da drauf. Dann sag mal Fenster schließen. Ja, mach mal. Das ist natürlich strange.
It doesn't want to open. The slide doesn't want to open.
No, the program is running, but it's
Aber
not
es war doch
showing.
vorher drauf.
Yeah.
Hey, maybe you have to switch on from LAN to WLAN, or okay. Just a few seconds, it will pop up.
Hopefully.
Hopefully. Yeah, we have to be positive. So no, it doesn't. Something's wrong there. Okay, I think we have
to close the program over task viewer. Yeah. So task manager, yeah. Task beenden. Ah, here we are.
Yeah, just slow, everything works.
So we are waiting. Second.
Okay, now we need the system view. Just a second, please. Yes, sometimes you have small problems, but
Reboot is always good. Now we have to wait for the picture. Here we are, coming. I see it. Yeah, here we are.
okay.
Oh,
I hope you guys see it also.
we get some data.
Yes, it's on the screen. Yeah. This is our system here that we have in our training center as a drawing. And so, Knut, it's your part to explain us in which direction we go here and down and up and left and right and everything. Okay.
So then I think I made it a little bit bigger. Let's have a try. Here we are. Scroll a little bit hinein. So first of all, we are starting at the compressor side. Here we have the empty compressor. Empty compressor is the left one there. Yes, that's the empty compressor. High pressure side on the left side beside, it's the parallel compressor, but first of all, starting at the empty compressor. Empty compressor, the high pressure side, going over the oil separator. Oil separator. I just scroll a little bit down. Oil separator divides oil and CO2, and the oil goes into the oil receiver. Oil receiver, you see it a little bit behind. Red one, yeah, it's a little bit not clearly seen, but
Yeah, we will show it
Is
later with
yeah,
the,
yeah,
the
with
camera.
the gimbal. From the oil receiver, we go, Johnny? From the oil receiver, we go one line to the empty compressor, one line go to the parallel compressor. Also, one line is going down to the LT compressor. Yeah, LT compressor. So that's for sure a short overview of the oil system. Later on, we show here we have also a little bit of CO2 gas where we release this gas, but this we will show later when we go with the gimbal again, showing the oil receiver. So then, oops, not down, going up and a little bit bigger. Here we are. So high pressure side. Here we measure the high pressure transmitter going over a sensor just for displaying the temperature on this side. And then we have here a three-way valve. Three-way valve. There it is. So three-way valve. Here you see, okay, the opening. Now it's showing 0. So we go the way where 0 is standing. So now we are going directly in this in this
Heat exchanger.
heat exchanger.
Heat recovery heat exchanger.
Sorry,
No
heat
problem.
exchanger. If the system is starting and the heat recovery is not active, then here it shows 100 and then we are bypassing. After this, we also have a sensor, so we can easily see the temperature hot gas before and after the heat exchanger. Then further we go line, following the line over a three-way valve, just bypassing the gas cooler or going straight into the gas cooler. Now we are operating 0%, so we are going through the gas cooler. There behind, sorry, yeah, this, there you have the three-way valves. Why do we have here a three-way valve? This three-way valve is clear. Activate heat recovery or not activate heat recovery. But why we do have here in CTR three-way valve? Easy. If the request from the building is so high that our rack has to produce very hot gas and much load, then it makes no sense to even work the CO2 circle over the gas cooler. Gas cooler is cooling down the system. It makes no sense if we have to produce much load, more load, then it makes no sense to circulate over the gas cooler. Then it's easy to bypass the gas cooler. But who decided if we are bypassing or not? Absolutely clear answer, our pack controller. But this pack controller gets a signal, gets a 0 to 10 volt signal. And here we have described what is working when. Normally from 1 to 6 volt, we are just driving the high pressure from subcritical up to the end point of transcritical. Boom, doors closed. Then you see here, if we are rising up, if the building has to get more power, more load, then from 6 up to 7 volt, we just cut off first, we just cut off the fans. Just go straight over the gas cooler, but no cooling because we are cutting off the fans. And from 7.5 up to 8.5, then we are bypassing this gas cooler over this three-way valve. So when we get a 0 to 10 voltage signal, and that's normal in Germany, that we get this from the building management, then we are heating up the system in this way. Okay, and behind over 8.5 voltage, when we get 9 or 10 volt, then we are normally create an output and start and separate heat pump. It's an option. Okay, so three-way valve, we are going through the gas cooler, and behind the gas cooler we are passing a heat exchanger. I'm just coming back to this. First of all, heat exchanger, and then going through the injector. Or if we activate the high pressure valve, then we are passing the high pressure valve. So here, ejector, high pressure valve. Yeah, where is it? Behind.
Yeah.
We will show this later with the gimbal later. So then pushing a little bit up, behind the ejector, just going with the medium temperature directly into the receiver. With the receiver pressure directly into the receiver, we present the receiver. Here we are. So we just talked about the gas here in the receiver. We divide here on this, in this place, liquid and gas. The gas will go here, first step, over the gas bypass valve into the suction line of the empty compressor. Okay? So here we have the bypass valve. And this line is going directly into the suction side of the empty compressor. On the other hand, when the load is very high, so we had a high request from the heat recovery, then we have here over the bypass valve an open degree, a degree open, that we can decide, okay, now it's open enough, we have enough mass flow to start the parallel compressor. Then this valve will close. I hope we can show this. It's very cold outside, but we have some tricks and steps to show this. Then this valve will close and the compressor will start. This three-way valve I'll explain later. First of all, then we are going this way over this heat exchanger. And now I'm coming back to this heat exchanger, why we have this here. You see this there behind, black one, yeah? Heat exchanger. Why do we have there a heat exchanger? We have to avoid that this compressor, the parallel compressor, the IT compressor, suck any liquid. And that's for why we have there on the one hand hot gas and on the other hand the suction side of the IT compressor. So I think this is clear. Then first of all, before we going back to the liquid line, then I will explain these little strange three-way valve. This rack now is old, I think 3 years.
3 years now, yes.
3 years. We have there an idea. 3 years before we had an idea. Why we do not use an IT compressor just for standing still all the time or most of its time? Why we are not able to use the IT, the parallel compressor, for also for another step of the empty compressor? So you see the way when this valve, three-way valve, will change its way, then we are sucking this way. We are closing this line and we are going this way. And this line is directly connected to the suction side of the cooling cabinets and cooling rooms, cold rooms. But you have to remember which pressure you have on this side and which pressure you have on this side. It's just a nice idea, but in practical ways, it makes no sense, because on this side, we have the pressure of 37 bar, 2 degrees. And on this side, we have the pressure on 30 or 28 bar, minus 8, minus 10. So if you change this valve, immediately you have this pressure on this side. And this transmitter will react immediately and will power up, and the whole system is not able to control anymore. So when you change this valve, we tested, you have to shut down the whole system and let it run again. So in real life, it makes no sense to use this three-way valve. So we here in our system, we only had the way coming from the heat exchanger going directly into the IT compressor. So this line is closed. So you see here the 100%. So we use only this way. Okay. Any questions so far for the circuit? If not, then I will go down to the liquid line.
Yeah, that's right.
Receiver, we are ending here. Gas, one way through the gas bypass valve, the other way into the IT compressor. Liquid, going down over a dryer, and then from the dryer over the heat exchanger. Here we have the
Yes, on the back.
dryer. There we have the heat exchanger. And liquid going one way to the cabinet, and as shown, outside cooler and the LT cabinet and LT outside cooler. Okay. On the suction side, easy, empty is going directly empty compressor, and LT is going this way, and over the heat exchanger going that way. Why we have here a heat exchanger? Because we also want to be safe that the LT compressor is not able to suck any liquid. So this is a heat exchanger, liquid on the one hand, warm liquid on the one hand, and suction gas on the other hand. So the last step, coming, suction side, LT over a temperature sensor and a pressure transmitter, hot gas from LT going directly into the MT. One line I forget so far. What did I forget, or what did I forgotten? I forgot the external injection for cooling down this line. You have to remember, then I just get a bigger slide here. So when this cabinet and this outside cooler or this cold room is shut down because temperature is cold enough, controller told our AKV, okay, close the line. We did not use any load anymore. Then we only had load from TK, only load from LT. If we only had load from LT, then we did not get any cooling out of the empty cabinets. No, we did not get any cooling. So we are working here on this point with 50, 60, up to 65 degrees. 65 degrees on the suction side of the empty compressor, I don't think it would be nice. The empty compressor wouldn't be happy about this. So one solution is to use a Danfoss AKV for a small injection and cooling down on this point. The other solution is to build in here a heat exchanger that's standing normally on the top of the rack. It's just an air cooler, cool heat exchanger. The room temperature of the machine room is cold enough to
Cool it down.
cool down here the hot gas.
How many? 20 Kelvin is enough.
Absolutely.
20 Kelvin.
Absolutely. So this is a circle. Empty, hot gas, gas cooler over the high pressure expansion. Normally we are working with the ejector here coming down into the receiver. From the receiver, liquid going into the cool cabinets. On the other hand, the gas is going back to the empty compressor. Any question about this circuit? I don't see.
No, at the moment
Question?
not. No. Okay.
We want to introduce the backside
Yes, with the gimbal.
with the gimbal. Mr. Gimbal? Mr. Gimbal, the gimbal?
Okay, we change the camera. Yes. It works.
Ja,
it works.
Schon. Du bist schon dran. Aber du bist doch dran, ich sehe doch ein Bild.
Ja, du siehst Bild, aber ich muss den Gimbal jetzt im Starten bringen.
So, okay.
We want to show now the oil.
Yes, so like the colleague said, the discharge side from the compressors coming inside in the oil separator first. And then from the oil separator, get the oil in the oil receiver. One thing, guys, in these oil separators, there are filters inside. Don't forget about that. You don't have to clean them every year or so. But let's say you have a real problem with dirt in the system, maybe from starting up from the commissioning of the system, and you change everything. Then also you should also have a look, of course, in this filter. You go then to the oil receiver, and from the oil receiver, we go back to the compressors. With this small 6mm lines, that's absolutely enough. Yeah. And then we go to the oil level regulator of the compressor. Each compressor here has a own oil level regulator. Yes, you see here the orange one goes here, and there's a shut valve everywhere inside. So that if you do something on the compressor, you can of course switch off close the valve and open it. And then we have this important line. Knut, you talked about that before. Between the oil separator, because we have still CO2 also inside. Then we have a difference. Here is the line. A pressure difference valve that opens 4.5 bar difference, and it's opening, and then we get the CO2 out of the oil receiver back in the receiver.
Yeah. So
Okay.
two questions.
Yeah.
Why is this valve mounted directly before the receiver? Why is it 4.5? And why do we connect this to the receiver and not to the suction side of the empty?
Well,
Nice questions, isn't it?
yeah.
So first of all, sorry. First
Yeah.
of all, we put this right in front of the receiver. In years before, we had it in directly behind the oil separator, oil receiver. But if this is opening, this valve is opening, it makes noises, you go crazy, definitely go crazy. It's too loud. And there, a company comes here, 3 years, 2.5 years, yeah,
To go, yeah.
and told us, okay, if you mount this valve directly in front of the receiver, then the noise will gone.
And it was gone. It was
Absolutely.
really absolutely quiet. And
Because-
before,
Because
was extremely loud.
the line is not shaking anymore. It's not visible that you are shaking, but you have so much power on this line that inside something is vibrating and it makes noise. Oh, no.
yeah. So this is the best position near the receiver. Give him a few meters from the oil receiver to the CO2 receiver.
So then, why do we have 4.5 and not 3? 3 maybe, and it's enough, but no. The real life shows us 3 bars differential pressure is not enough. We tested this, and it's not, the problem is not the LT compressor. The problem is not the empty compressor. The problem is always the IT compressor.
The parallel compressor.
Yeah. And that's why we have to mount there a 4.5 valve. And because of the empty compressor, the IT compressor, the parallel compressor, the IT compressor, we have to mount this on the side of the receiver and not on the suction side of the empty compressor. If we put it down there, then we did not have enough pressure to put the oil coming back into the IT compressor. So these are 3 major points that you have to recognize if you build a system, right? If you want to avoid noises, just put this valve directly in front of the receiver, put an 4.5 differential in, and be aware that the empty compressor always gets oil. So easy.
Yeah. That's very important. Yes. Okay. So far the circle. One thing also, if you see the drawing of Danfoss on the screen, you have everywhere the pressure and the temperatures, but we always also, of course, suggest to use additional gauges as well, because then you can always have with one look, you see, okay, pressure is rising fast. The gauges are faster than the temperature and the pressures in the system, because, of course, the system always has a delay. It takes a few seconds to show you what's happening.
It's electronic, but it's just electronic. It's always a little bit delayed. So,
Okay.
Okay. How to select liquid injection valve? Easy, because you know which how many Volumenstrom. I did not recognize some English words, so sorry.
Mass flow.
Yeah, you really know which mass flow here is coming from the LT side into the empty side. And you always have to recognize that you have to cool down the system about 20K. 20K is, my opinion, is normally enough. If you cool it down from 50 to 30, it will be enough. So, mass flow, differential 20K.
Oh, okay, we're on again.
So, mass flow, 20K. So you have your load, and that's why that's how you can select an ejection. Which speed of the flow is recommended for discharge line and for gas cooler receiver line?
That's a good question.
Speed.
Yeah, he means meter per second.
Yeah, but that's the question not for the controller. Is it a question for the manufacturer of a compressor?
Yes, and that's why we have Frank here. Frank, please come here. We forgot to introduce him. He's the head of training here in BOCK at Frickenhausen. His name is Frank Alisch, head of training. He's doing all the trainings in German here, and he is the head of the whole training center. The question, I will just translate it. Die Geschwindigkeiten in einer
Nein, Heißgas.
in der Heißgas.
Discharge und Gaskühler.
Ja.
Also die obere Seite hier. Welche Geschwindigkeiten musst du da einhalten? Nee.
Aber ich schicke ihm eine Folie dazu. Ich habe die Geschwindigkeit. Ich schicke ihm eine Folie dazu.
Okay, kannst du holen oder jetzt? Oder?
Kannst du holen? Das ist jetzt ein bisschen schwierig, weil Janni darum macht.
Okay. We will prepare this. He has a
Hier hängt das an
A slide?
Präsentation hinten ran.
and he doesn't know it now from in the head or how you say it at the moment. But we have a slide. We will put that on the presentation as the last slide on. So where you can see the recommended meter per second for each line, suction line, discharge line, liquid line, and so on. I hope that's okay for you, Mr. Andriy Savchuk. And the other question was from Ruslan Timonov. Okay? Thank you for the questions. Go on like that, guys. Just a second. Okay. So, then the next part, yes, we said commissioning of the system. Of course, our system is pre-filled. It's not totally empty, but we have additional valves in the system. So where we could always, when we stop the engine, because it's not running all the time, it's a training center. We are not a real supermarket here. If the training is over, let's say in the afternoon today, we stop everything and we put all the liquid CO2, we pump it in the receiver. And then we have these additional valves where we close the machine. And then we have only the gas in the other part of the system. But today, maybe, I don't know if you see it, guys. Yes, here we can see this is a measurement for the amount of the liquid gas, of the liquid CO2 in the receiver. And it says we have 59%. And it's a bit low. So we want to fill it up a bit. And that's the thing that will start now. First, we will fill up the receiver with additional CO2, but it's the same procedure as if you fill it up, if you have your vacuum pump on it, yes, you evacuate the whole system, minus 1 bar, absolute. And if you finish with the vacuum pump, yes, first you learned this morning,
I hope so that you learned this.
The triple point. So that means we don't put liquid CO2 in the system. We start to let gas CO2 in form of gas into the system up to 8 or 10 bar. 10 bar, it's
10 bar, you are absolutely safe.
Quite okay. Frank is preparing that. We are preparing the bottle. First of all, why is 10 bar okay? I will show you. We had the bottle now for several hours here in this room. We have approximately 21 degrees in this room. And if you take here the pressure of CO2, I hope you can see it. Let's say 20 degrees, we are here, guys. So 20 degrees is 60 bar. Yes? So that means in our bottle, we have a pressure of 60 bar. So it's absolutely no problem to press additional CO2 in the system where we only have 10 bar at the beginning after putting gas in the system. So I show you the bottle.
Here, before the beginning.
Yeah, we have to open several valves, right?
Before we start, okay, ich wollte das nur erklären. Okay.
Yeah.
Yes, first I want to show you the bottles. There are different bottles. We have a CO2 4.5 that we use. That's high quality, of course. You always have. The higher the number is, the more or the less water you have in the CO2. So this is 99.995% volume is CO2 in this bottle. And then what you also have, I don't know, it's not on this bottle. Normally, wo ist denn das Tee? Yeah, that's the old bottle, sorry. If you have a line here, wie ist das aufgezeichnet? Yes, if you have a line here on the bottle of tea, then you know that you have a pipe inside the bottle that goes down. And then this is one of the bottles that you use for filling liquid. But you can order, when you order bottles, you can order one without this liquid line that goes down to the bottle. And then you can fill it, yes, as a gas normally inside. So there are two different bottles. That's only what I wanted to show you. Okay, and now we have to open the valve before we start.
First of all, just connect the bottle to the pipes.
Okay, to connect, you see the gouge here and the line of the gouge, the hose. Yeah. You have a connection here that goes directly into the receiver. So this line goes directly here in the line of the receiver.
No. Jetzt gehen wir nicht direkt ins Receiver, wir gehen in die Flüssigkeitsleitung.
No, sorry.
Liquid line.
In the liquid line. Oh.
Just in front of the dryer.
Yeah, okay, that was my mistake. Here, yes. We go with this line here in the liquid line directly here in this line in front of the dryer. And this valve is closed still. Yes, and always we fill liquid over the dryer, of course, because if we have some moisture inside, then it's important to go over the dryer. Okay. So first, we let the pressure from this side to this side, that we have no air in the host. So now we can see the pressure now we have in the liquid line is 22 bar. It's only gas at the moment, yeah. Okay. Now we assume that, or I think our bottle has about 60 bars. 20, yes. 55 or 60 bars we have now in the bottle. Okay. Please remember, Yanni, kommst du mal? 59% of the receiver at the moment is already filled. Just stay a second. Maybe you can see it.
59, yeah.
Yeah, 59. And we need now additional 10%. Okay, so that means 59 it's about approximately half of the receiver is full. Of course, you have to calculate. Yes, never fill up the receiver absolutely full to 100%. That's not recommended, of course.
For start the compressors,
Yeah.
heat compressor.
Oh, we forgot that. Yes, that's also one important thing. Before you do the commissioning, before you start the commissioning for the compressors, it's very important that the oil heaters are on, that they have power. It's the best if you do it 24 hours before. So one day before you start, you just give power to the oil sump heaters so that we have a nice warm oil before we start the compressors. So here it is on this side, yes. The oil heater, very important. Yes, and we did it. Yes, of course. Yeah, just check it then. You can put your hands down here and you feel, oh, yes, they're getting warm. They are warm. And if they're all warm downside, no problem to start with the commissioning. Okay, so, and then,
Erstmal die
yes,
Hochdruckleitung.
the first, yes, like I said, we have the additional valves inside. The high pressure valve is the first one that we are opening now very slow. Yeah, guys, not at once. We started just very slow. Okay. Now you hear the high pressure valve. Can we hear it down? Yeah, we can hear it. The high pressure is going into the gas cooler outside. Yeah. So we have a pressure, the pressure equalization starts. Pressure engine. Yes. Yeah. Here we can see this is the pressure. Yeah, okay, we can do that. Where is it? Oh, can you show it? You can see the pressure. Yanni?
Ja, das sehen die doch auf dem.
Ah,
You see it on your screen.
you have it a parallel screen. Sorry. Is it still on the parallel screen? Yes, it's on.
Yeah. Here we have
50 bar.
50 bar. It's going lower, and here you see 43. It's going higher. So, and the noise you hear, it's because of the pressures coming from here, going through the ejector or through the valve backwards in the outside pipes. And now we have equalization.
Yes, you see 45 bar to
45
49.
to 49.
Yeah. And Knut, we have some more questions.
Oh, more questions. Oh, yes,
Yes.
please.
Mr. Ruslan Timonov, how to select liquid injection valve? Sorry, we had that before.
First
Okay.
we have to.
Mr. Andriy Savchuk is asking which speed of the flow.
This we also have.
We have
the
the
first. The first.
Yanni, you have
humidity.
humidity, HFC, PO oil, high temperature acid. Yeah, that's a special. Yes. Of course, we have to avoid humidity in the system. It's the same like the systems with synthetical refrigerants, of course, because as Mr. Hussein is said, the danger is there that you get acid in the system. That's with high humidity. But that's one thing. Yes, guys, today we have only one day. Normally, the training here, 2 days,
Absolutely.
is going over 2 days. Then we have a 1 day only theory where we also talk about all this stuff like humidity in the system, what can happen, how does humidity come inside the system, the acid producing the acids inside the system, and so on, that you have to be very careful with that. But today it's really too short to talk about all that. Okay. So far, we go on.
Jetzt
Wie
brauchen wir den NK verdichten.
Yes.
Den musst du noch auf Auto stellen.
Ja.
Und wir nehmen das
Nein.
Regal zu füllen.
Nein.
Nicht über die Kilo. So. Willst du erst komplett Gasblock absaugen oder was?
Wollen wir nicht
Wir wollten doch nur füllen erstmal. Wir wollten ihm zeigen, wie der Füllstand hochgeht. Nicht nur absaugen.
So we are discussing now which method we will use to fill the system. Ja, wir wollten das 10 Kilo reinhauen.
Bitte. Also, first
Okay.
of all, starting the empty compressor.
Yes, always we begin with the empty compressor. That's the first thing.
Just switch on, but nothing
Nothing
happened.
happens, of course.
Weil du so gewackelt hast, dann musst du neu starten.
I hope we're still on. No problem with the camera.
Oh, what a nice guy is there. Is freezing. The nice guy is freezing.
We'll be back soon. Just a second.
Ach so. Ja, Entschuldige.
Mhm.
Ja, jetzt macht es doch.
Just a
gerade.
second, guys. Yes,
Here we are.
here we are
Okay.
again. Okay, so we switched on the middle temperature compressor on automatic, and then additional.
Yeah, but it's not running because we just have to switch also on the frequency converter.
Yes, we did it. We switched it on. Also automatic or hand?
Automatic.
Also an automatic. Yes.
Yeah, put it on, please.
It's on.
Die Möbel dazu auch.
And additional to that, we start with the small middle temperature cabinet. We just switched it on so that we are also opening expansion valve in the system. So, I don't know if you hear it, the middle temperature compressor starts. And we are opening now the bottle and let the CO2 in the liquid line. Here you can see the pressure now of the bottle, and this is still in the liquid line now. And the compressor stopped again. Why did it stop?
Because of the liquid line is closed.
Yes, the liquid line is also still closed. We have to open slowly the liquid line.
No, no, no.
Yes, den aber noch nicht.
Yeah.
Okay. We are opening slowly the liquid line valve.
No, no.
No, you don't.
Jetzt kommt der
Frank, du darfst, aber Michael, das solltest du jetzt gerade nicht anfassen, weil wir
Ach
wollen
so.
ja das.
Ah, okay.
weil wir
This
wollen
one
ja
has to
jetzt-
be
du willst
closed.
ja jetzt da oben füllen. And you see, suddenly,
Jetzt kannst du sagen, Möbel sollte was zu sehen sein, dass das E-Ventil aufgeht. Das könnte man zeigen eigentlich. Ja. Und jetzt geht
So, okay. The expansion valve on the cabinet has opened 91 degrees.
why?
Percent.
Because we have here 36K of superheat. And you also see here, just, it's coming very quick. Whoop. Why our compressor is not running? Because we have -10 and we just want to have -8.
der Druck steigt.
Yeah, yeah.
Yeah, we have to wait till the pressure is rising again. The controller says at the moment.
Komm mal her, hier können wir es noch
Break.
zeigen. Lass es jetzt zeigen. Das ist der Druck.
Ah, now it started again. Yeah, a bit of noise. So next step is
Jetzt müssen wir warten. Jetzt haben wir die
you have to wait.
Jetzt ziehen wir eine über, dass wir über die Flüssigkeit rein.
So now the cabinet, the valve is opened, and
So we just have closed this valve, right?
yes,
We-
at the moment it's
Here is connected the bottle, and we're just going, oops, not this way. We are just going that way with the liquid line. And we are just filling, oops, sorry, over this compressor, going the high pressure side is running. So now we have 57, here you see, 57. We start at
56 it was.
50, 50, 56, 50, 53, I think. Now
Now
we
you
have
60 almost.
this is not normal.
Gleich noch mit Heels.
Nein! Something is not nice. Our system is not working as normal. I think the high pressure valve or the ejector is just crying. I don't know why. So now we
Yeah,
have
but-
60% of filling degree.
Yeah. 62. We will fill it up to 65. Yeah, the noise that you hear here, maybe it's coming from the ejector at the moment. It's somewhere in between, work, not work.
I think you just close the valve.
Close the-
Hallo. Hör auf.
Irgendwas passiert ist gleich. Ha?
Irgendwas stimmt hier nicht.
Was habt ihr gestern gemacht? Ah,
Irgendwas stimmt hier nicht.
so what's wrong today?
So, für dich das aus. Jetzt saugen wir einfach das Heißgas hier ab. Also wir holen uns jetzt noch nicht das Heißgas, sondern das Löschgas raus. Okay?
Mhm.
Just wait. I have to start the compressor again.
Okay, so we switch on the middle temperature compressor again, and now we open the flash gas pipe.
Das für uns
Also the valve.
Because
of the flash
why we are doing this, you have to remember here we have a valve and we have there 55 bars, right? But we only want to have 37. If you just immediately open this valve, then you have 55 immediately on the suction side.
We don't want that.
And that's definitely not the right way. So here you see it's opening a little bit.
Okay.
Erklärt mir den Ventil, das ist das jetzt vom Handband. Aber was das Ventil macht, mache ich von Hand.
Yes, I just told the
Yeah.
guys we are just No. Hör auf, mach zu.
There's something else today. Is it an ejector or?
Ejector, ja. Und dann
Ja,
willst du die Hochdruckregelung vielleicht einschalten? Dass wir das Hochdruckregelventil nehmen?
It's like a normal commissioning. Very often, from time to time, we have a problem, but we will go through this. It is life.
Yes.
We had a strange sound at the moment, and we are discussing: is it the sound coming from the gas injector? He was not running. Also, a few. When was the last training?
Mach
A few weeks.
ich mach noch mal einen NK an. Oh ja, schnell. Der NK, warte, nee, du musst den brauchen wir nicht, den Druck. Wir haben jetzt gerade -2.
Ja, da müsste eigentlich jetzt laufen, oder? Ich auch von Hand absaugen, wenn du willst. Kannst du machen. Ja. Das war absaugen jetzt.
Okay. Now the compressor started again. Sound is better now.
Also wir saugen jetzt einfach erstmal ab, okay?
The valve is still. It's closed. It's
Mach mal wieder auf ein bisschen.
Now we will open again.
Ich gucke hier drauf, das habe ich jetzt nicht gesehen. Also wir haben eine Zeitverzögerung, deswegen.
Yes, we have a delay at the moment of the pressures and temperatures you see in the
Wieder hoch, siehst du?
Nein,
picture.
ja.
Oops, pardon.
Okay, now the noise is away. No, the
Yes.
noise is gone.
Yeah.
No, das ist schon genau richtig, was du da machst. Lass mal
So-
so.
Du kannst es auch jetzt ganz zeigen, weil wir da anspringen und da anspringen. Weißt du, was ich meine? Kannst die Kamera da oben anmachen. Aufstellen.
Ja, warte noch. Okay.
Aber
Now,
du könntest vielleicht noch mal zeigen, dass wir hier spezielle
Schon mal laufen.
we do have here a special frequency.
yes. Here at the training center, because we guys from BOCK are always here, and we can go down with the frequency of the middle temperature compressor, the 4-cylinder, down to 15 hertz. And there's also, if you hear, you see the compressor is running, no vibration. It is absolutely astonishing. It's totally quiet running, and it's running at 15, gentlemen, hertz. That's really fantastic. But do we still have the problem with the system, or
No.
now it's okay?
It's
You have closed this valve, and so if you close this valve,
I open it.
you have opened it.
I don't know why this noise is coming.
Yeah.
Mach uns ganz vorsichtig, okay?
Ja, sehr gut.
So at the moment we don't know why we had this noise before. You are here. We opened the valve to the ejector, and then it's gone. We will wait. We will do slowly.
Yeah, but now someone can ask, why is the empty compressor just running with the minimum speed? Because we have 43, 41 bar. We want to have there 37. So does it make sense that the system is not running with the maximum speed because we have to cool down the pressure in the receiver? No, it makes no sense because we want to have 37. Now you hear we are now in the range that the compressor is running normal.
Now it's coming.
But when we are in a safety mode and for the receiver pressure, we have a minimum and also a maximum pressure that we don't want to have in our system. If we are above this maximum receiver pressure, then from our point of view, it makes no sense to speed up the empty compressor, because when we speed up the empty compressor, we are coming down directly over the high pressure side, directly again into the receiver pressure. So from our point of view, the system is when the receiver pressure is too high, then we are shutting down the compressors, let it run on minimum, and to check what is working and what is not working.
Okay.
So the valve is not good.
Okay. Now we're opening the flash gas. The bottle is closed. We have filled up to 66%. I think that's okay. Yeah, we leave it like that. 68% even. That's okay. That's what we wanted. Okay. Can I open? It is open meanwhile. Yes.
So, what?
Flash gas valve is open.
Yeah. Frank is showing the liquid level.
Das haben wir 70%. Und nachher, wenn wir 40 aufmachen, dann zeigen wir, dass die wieder wegpusht.
So at the moment, it seems to be full on this. It seems to be about somewhere here, because this point is 64%. No, it's
Zeig mal. Zieh mal richtig ran. Das ist das CO2.
I don't know if you can see it, guys. But you can see the bubbles of the CO2 inside the liquid.
Das haben wir schon runtergesaugt.
Yeah. Okay. Now The suction pressure.
Not
Right.
now, not now.
Not
Just first of all, what we explained now is we have to be sure and we want to have to be safe that only the circle of the high pressure side and the receiver side is safe. So you have to remember that our system is coming from a standstill version. We just shut all the valves before and behind the receiver. So all the liquid and the whole pressure is in the liquid, in the receiver, sorry.
It's still closed.
Yeah, on the liquid line, absolutely. So first of all, we have to be sure that the receiver pressure is on the right range. And now we are able to check this. Okay, we want to have there 37. We have now we a little bit low, but that's okay. First of all, we just start this circle. Open all the high pressure valves and open all the valves of the gas side of the receiver, bringing down the pressure of the receiver. And now we are able to open the liquid line and then start slowly the empty side, not the LT side. First of all, starting the empty side, that the empty compressor is running in a smooth and in a perfect way. And when this is perfect running, then we are able to start the LT side. If we start both sides together, then maybe we have too much load. The empty compressor is not able to put it away.
Yeah.
Okay.
It has to run safe and stable.
Yeah.
We say stable.
Absolutely.
And then after it's running stable, then we'll switch on the low temperature.
So
okay, but
then it's three-way valves. Check. We are running 100%, so we are running this way, but the parallel IT compressor is standing still. Here we are running the way 100%. Heat recovery is not active, and here we are running 0%, so real 0% going through the gas cooler. So now we are open the liquid line.
and also like always a bit slowly. Yeah. Yes. Not 100%, just I open it about 20% at the moment. We can hear slowly liquid. And Knut started again the cabinet so that we have a load. And now you hear the
Frank, machst du gleich das andere?
equalization.
Weiß ja keiner. Das andere Ventil.
And now it's okay. I open it 100%. Sollen wir es auch zeigen? So. Okay. Now the pressure should
Ja.
start to rise again in the suction line.
Now you see we only start this cabinet 41%. I hear the noise of the CO2 going through the cooler. Here we have the superheat. Yeah, now the system is running. I think we have not much load. I start the outside. Also the outside.
It was too late.
Yeah, a little bit too late.
Outside the evaporator for the middle temperature outside.
Outside
For the-
evaporator and the empty cabinet.
yeah, because
LT is just shutting off.
you just want to have more load, that's all. So it takes a few seconds.
Ja, da ist er. Ja, die kannst herkommen. Musst ja andere mal. Sag mal, dass Jan hierher kommt.
So now they will start again immediately.
Yeah.
Never hurry during commissioning. Never hurry.
Absolutely.
Always safe
CO2
and
system
slow.
is reacting very fast, but always be sure what you are doing and don't hurry with your reactions.
Yes.
Oh, just
Wait.
wait.
Just wait. It will come. The empty.
Ja, was willst du?
Now it started again.
Guck mal hin.
Oh, it goes. It pumps up. Ah, yes. Now you will start slow to get in the operation.
Immer noch sehr.
Yeah, okay. We have to think about even outside. We have only 2 degrees today. It will be a bit difficult to get load today, but it takes a bit. Normally, it goes quicker if it's warmer outside.
Absolutely.
But it's winter time, gentlemen. We cannot change it.
That's the way it is. Ja, jetzt liquid is filling the lines. Ja.
Checkst du das aus? Das ist immer besser.
Yeah, I just sorry. I just have a look on this temperature because this is our controlling temperature. It's now, and now it's coming. So here you see we did not have any liquid in our cabinet. Definitely not, because 92 percentage opening degrees of the AKV and 23K. It's not normal. Definitely not normal.
Yeah, but it will.
Where's the
come
liquid
to-
line? Where's the liquid gone? Where do you put it?
Ich stand gerade seit Weihnachten, da muss ich mal Handy zum Anfang.
Have maybe we forgot another valve? No,
I don't think
we
so.
don't have any more valves.
On the high pressure side, no. On the suction side, no.
Yeah, what was the feeling is, but it's still at 64%, so it's okay. I think it's today. It just takes longer. It's cold outside. 20 Kelvin. Yeah, it's going down. Yes, it's good. 13. What do you
We
want,
have-
Knut? Everything is here.
We have to wait. Just wait. We have to wait. So,
And-
but then I think we can start LT also, right?
Really?
Kannst du auf Auto gehen da? Eine Uhr auf Auto, links, Auto. Links.
Ah, sorry. Frequency inverter. So now we'll start with the low temperature compressor.
Besser, wenn du kommst. Ja, weil dann mit der auch betont, mit der angeht.
Ah, yes. Maybe you see now all. This one is running now stable. That's the middle temperature. It could be a bit more, but yeah. When the low temperature,
Did not have more.
Du kannst ja nicht.
yes, but now we will get more load of we will get the discharge gas of the low temperature compressor. Now
There
it
we are.
starts. Low temperature starts. It starts full. Yeah, of course. It's okay. It's okay.
Aber da ist auch eine Schwingung drin, die haben wir nicht.
And now you see
Komm zurück. Komm, zeig doch beide.
we have the discharge gas that we put in the press in the middle temperature compressor, and that's why the load is getting higher and we get a higher frequency. So you see here, low temperature started, discharge temperature is rising here, and so it is also the load for the empty is getting higher. Maybe good, yeah. Okay, now
Dann nicht der Hochwert, Janni. Komm mal her, wie der Hochwert jetzt hier.
now it starts.
Weil der
Yes.
Podcast da ja reingeht.
Yeah, habe ich gesagt.
Ah, gut.
The discharge going in the suction pipe of the middle temperature, and you see low temperature compressor is coming, rising with the frequency, and now we get some action in the system.
Du hast es dauernd die anderen Nummer noch reingemacht, oder?
So now we have opened the cabinet of the low temperature cabinet. The valve is open, and the outside evaporator of the low temperature is also open. So we are getting load now. Load. So now it sounds quite good.
Janni? Die Maus? Danke.
Now we see.
Here you see -26. So LT is running about 100%. So I will shut down my mic that you hear the noises of the
Okay, guys. We just tried to get more sound of the compressor, but the microphone, they have a filter inside. I think they cut off the frequencies. So we go on then.
So I
How
think
about
now
heat
we are
recovery?
a little bit of working. How it looks like. So we have stable opening degrees on the LT side, stable opening degrees on the MT side. LT is running -28. LT is running -11. So the receiver pressure is at 33. 16% of the gas bypass and 13% of the injector. Yeah. So I am happy so far.
heat recovery?
Just wait a minute. I just have to look. Why is it going down? LT is okay. LT is not defrosting, so I don't know why it's coming back. Okay. Yeah. So now the normal CO2 system is working, cooling system. But we want to show also heat recovery. Heat recovery. So,
That's the next step. I
Yeah.
will show the heat recovery, yes.
so first of all, I think we start with the yeah,
We switched on the
pumps.
circulation pump of the heat recovery.
Yeah,
Yes, it's working now.
wir starten die BAG. Nein, da. Pump of the heat recovery. Das
Jani,
muss man natürlich dem Herrn Regisseur sagen.
Gimbal,
Hier, hallo? Der Mann arbeitet einfach nicht mit.
okay.
Our master of television is not working with us.
You need the other camera. Okay,
Yeah,
here
here
we are.
we are.
So the pump is started. That's the first. And then that's our heater. So we just switched on the second circulation pump that will circulate.
2 Sekunden.
Wieder da? Jetzt? Okay. So back again. Switched on the second pump, the circulation pump for the hot water. Here you can see. Then we go into our heater. We are heating up the room. At the moment we have 20 degrees of water temperature, but you will see that this will rise very fast.
No, not now. Not now very fast because
No,
of-
yeah.
we are not running transcritical. We are just running subcritical. We are just telling all the pumps they have to start. And now we are able to. Sorry, I have to stop because something in our system is making noises that's definitely not normal. I do not know what and how and why, but something is strange today. I think it has to be something with the year 22.
Maybe.
Okay, but coming back to our system, now we have high pressure of. Yanni, just give me a here we are. Now we have here high pressure of 61 bars. We are not working in transcritical. So here you see our signal coming from the building management system. And this signal is now influencing our high pressure side. And our building management system is sitting here on this side of the electrical panel. And here we are influencing this with a POTI.
Yeah, because we don't have a management system in the house. It's a simulation.
Do we not have a building management system here?
No,
And
we're
here
not a
you
real
see,
supermarket.
I just rise it up and immediately you will see here change. And if you see here change, then you also see here change. But it's not, be sure, it's not a click clack. It's always converted in a time and in a KP. It's a PI controller. That's, you always have to be aware, right? And you also see, Jesus, here we now have a 0. So we are not bypassing anymore. We are just going through the heat exchanger. Yanni, you are laughing. What you are laughing about? Me, my person? No.
Something is funny. So yes, we're going now through the heat exchanger.
Yeah, here you see we're just starting at 2022, coming back 21, but on the CO2 side, you see also here we in front of the heat exchanger we are 85 and behind 55, so 30 Kelvin are going here in the heat exchanger. But why do we not? Oh, it's 20 before 3 o'clock. I think I have to. What set point do we have there on the? Just stay. 65. Yeah, it's run. It's coming. Now it's coming. It's coming. Here you see 83. Now I push up the 0 to 10 volts signal. So we are here now in between 1 and 6 volt. We have there 3 volt. And now we are pushing up the high pressure side, pushing up the temperature. And here you see also the ejector is closed. Why is it closed? Because we need more pressure on the pressure side. Here, this has to be rising. We want to have there transcritical. Yeah, because it's cold outside. '67. You have to remember that our transcritical point is at 73 bars. So let's see if you see any changes or hear any changes. I don't think so. Here we are. Now we are working transcritical. And nothing happened.
Just running.
It's just running. Yes, baby.
Huh? Yeah. So, and now you can even see, oh, the water is beginning to heat up.
Yeah, 26. Yeah, 27. We are rising up the temperature on the high pressure side, 90 degrees. Coming back out of the heat exchanger, 31 degrees. And now I hear my ejector is already working because now we have the pressure to what we want to. And now you see the ejector is working at 30%. Yeah. The system is running now quite well. Now we have 5 voltage coming from the building management system.
Can go higher.
95 degrees. Yeah, but too high is not. It's not definitely
It's not needed now. It's
But now we are working in a very stable situation.
yep. The temperatures are also quite good for
Here
heat
you
recovery.
-9. 50% of the. I don't think that the IT compressor will start because this is too low. This opening degree of the gas bypass valve is definitely too low. I think I program it on 40%, 1 minute above 40%, then the parallel compressor wants to start. Let's make an overview. So, yeah, 80 bar. 80 bar. Ja, ja.
Die auch schon Automatik gegeben. Wenn wir die
So, but if we go further, I think I have to explain something because we just forget, or what we just forgotten a line. We forgotten a stupid line. You can see here on the left-hand side of the receiver, there a liquid line going to the left and coming back. What is it? Michael, what is it?
What is it?
I don't know.
Yes, we know what it is.
Do we?
Now, yes, we can use this for air conditioning
Right.
in a natural circuit, you could say.
But if this is a heat exchanger, where is our expansion valve?
we don't need an expansion valve because the temperature, if you look at the temperature in the receiver, it's cold enough.
Oh, 1.2 centigrade degrees.
Yes, cold
Perfect.
enough. So,
So this would be nice. Then I think we are able to start this water circle,
yes,
and
I
then we get a flooded heat exchanger and get cooling out of it.
yes. I mean, it's cold enough anyway, but let's cool down the
Yeah.
room a bit, okay?
Let's
Okay.
make Yanni. Let's make Yanni a little bit cold.
Okay, okay, we will start the pump for the air conditioning pump. We will start.
Macht die
Okay,
Leute
guys.
nicht schlecht.
We start the air conditioning.
We have some problems with our cameraman.
Switch on. No. It's opening, it's starting, and we can show you the pump. Look at this. So guys, we started the air conditioning pump. Here is the heat exchanger for air conditioning. The heat exchanger, yeah, we go with the water in the heat exchanger and we're coming out here. We're cooling down the water for our air conditioning with this 1 or 2 0 degrees that we have in a natural way. Yes. The water of the air conditioning is at 20 degrees at the moment. We can see here, and we started to cool it down. And that was very quickly, 20 degrees coming back, 10 degrees going up to our air conditioning, to our air cooler outside, inside here. Yes, and this is of course the sensor for flow that you have, who makes sure that you have the flow. If you don't have a flow, then it's quit off the system and to avoid ice in the water. Okay, and that's all that we have here, and it's totally enough for the air conditioning system. We have one air cooler here, and we have also in our server room, where we have some servers. Here, we also cool down the water, the air in this room. And we have even here a receiver which is connected here. And we also have a circle, and we use the air conditioning for these two rooms also. And the system is running. Okay. Great, what you can do all. You can cool, you can heat. Okay, Yanni, is it cold coming down? Yanni is freezing. Okay, so far the system is running stable. Low temperature, he's working at full load, 60 Hertz. And now the parallel compressor has started also. And now you see, when the parallel compressor is starting, you don't have so much load on the empty compressor, and it's coming down.
Oh, sorry. Yeah, 25%. And
25%
see also
on the
here the
parallel compressor, and
this valve is closed because it is running.
25 Hertz.
And here you see air conditioning coming from the building with 24, and we are going back 14. And here you see 0 degrees and 12 degrees on the suction side of the heat exchanger. Yeah.
Yeah, it works.
So now I am happy. All what we want to show, we show. Perfect. Ejector is working. Yeah, I am happy, guys. And
Okay,
ladies.
so that's so far. Can we start with the discussion, with the questions, or what?
I
shall
think
we-
if we do not have any questions for our circuit, that we can show something else, then I think we will end by presentation our rack, and I will slowly shut down the whole system.
Yes,
and
of course,
then-
because
We are able for any discussion.
yes, because it's a bit loud here at the moment. You
Yeah.
can shut down. So we
First of
go.
all, just
Yes.
shut down the air conditioning. Da.
Ja, jetzt leuchtet aber grün. Okay.
So, first of all, what I will do now for the shutting down the things, just shut down the air conditioning.
I have.
Then I will slow down the heat recovery by decreasing the signal, but not in the way that we just go down to 0, just slowly. You hear now the things are stopping. I think now the IT compressor, yes, IT compressor is shutting down because of the receiver pressure is low enough. Yes, we are there on -1. So the IT compressor has do his work. I just also shut down the outside LT compressor, cooler, sorry.
Evaporator cooler.
Then the LT compressor is running down heat recovery. Just I have to open the, just go down with the signal. With the signal, what kind of pressure do we have there? 75, okay, it's going down. But it takes some time.
Yeah, a bit
So,
of delay. Yeah.
just please, if you have any question, there's just two options. Raise your hand or just write anything down. Also, if you are happy with us, happy with my red shirt and with his blue shirt, whatever you want. But first of all, I have to check also parallel the function of the system. I think I cut also the LT complete.
Low temperature
Shut
compressor.
down
shut down,
LT.
yeah.
Shut down LT because now we are running at minus. Schatzi, das kannst du doch nachher wieder anmachen.
Nee. Wir lassen das heute mit dem Signal, das haben wir. Wir sind ja gut von der Zeit.
So, 6 volt. I now cut off the signal for the heat recovery complete.
71, so we're almost subcritical again.
Yeah,
No, not-
subcritical. 66 is the set point now. We're going down slowly.
Subcritical again.
Now we can delete the signal for the heat recovery. Pump is shutting down. The heater we will let run a little bit. Now 30 degrees. So, yes.
If you have a question, you can make a hand or in the soft.
Yes, Sergius is back
Sorry.
again. If you have questions, you can also have ask him in
In English or Russian, just making the software, you can make a hand over and we will switch on your microphone. Если есть вопросы, в программе можно поднять руку вверх и задать вопрос или написать его, как удобно.
Okay, so not many questions today, so that's always a sign that it was almost clear. I hope for you it was almost clear. Okay. Just.
Ja?
Was ist mit dem Ton?
Ton ist weg.
One, test, test, test. One, 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 one. Test, test. One, one, one. 1, 2. I can count to 3. 1, 1. Oh, bei mir ist rot.
Okay.
Yeah. Okay, guys. So if you don't have any questions anymore,
Yeah.
I think, yeah, we finished. It was at the beginning, we had some problems with this strange noise.
Yeah, noises
We don't know exactly where it's-
from the ejector. I don't know.
It was not the compressor, guys. It was
No,
the
no, no.
ejector.
It was a Danfoss ejector.
Additional question.
Oh yes.
Oh, we have a. Will Mr. Maximum Davidov is asking, will such low capacity refrigerating machines up to 1 kilowatt,
Up to 5 kilowatts.
up to 5 kilowatts and single compressor ones be produced?
Produced.
Yes,
Yes.
produced.
We launched in January 2022, this month. new range of HG12. The capacity is from 1.7 about cubic meter per hour.
Yeah, kilowatt. 1.7 kilowatt.
1.7 cubic meter. It's this displacement.
Okay.
В январе этого года мы вывели на рынок новую линейку двухцилиндровых компрессоров HG12, где мощность начинается примерно с 1,7 кубических метров, не мощность, а компрессор размером с 1,7 кубических метров в час. То есть, ну, мощность зависит, конечно же, от рабочей точки.
Okay. Thank you for your question, Mr. Davidov. Oh,
In any case, you can,
we have still. Oh, I can't read that.
будет ли достаточно комплектующих в этом году для сборки агрегатов такой мощности Российской Федерации? Ну, на самом деле, для нас это уже серийный компрессор, который... У меня зеленый говорит. Это у нас серийный компрессор, который, в принципе, производится в течение 2-3 недель, поэтому с нашей стороны, со стороны производителей компрессоров, здесь вопросов никаких нет. Единственное, конечно, что, ну, я думаю, что те же теплообменники и вся остальная автоматика, она существует. Если будет интересно, можете написать нам просто на e-mail и дать конкретные данные, конкретную техническую задачу.
Okay. What was the question?
Sorry. The question was the question was if it is already enough spare parts or components on the market to build such a small system.
Yes,
And
of course.
I said
Yeah.
yes. And especially if it will be available in Russia, for example, or Russian market. But I said from our side, we already produce this compressor like standard compressor. It's not an issue. And from company Danfoss and from other companies who produce maybe different components, it's
Absolutely. We have small gas bypass valve. We have small high pressure valves. My mic is, oh, sorry, my mic was turned off. We have small gas bypass valve. We have small high pressure valves. So anything what we produce is also not only in big things, we are producing this also in small things.
Jetzt kommen sie raus.
Next question from Maxim Davidov. I will translate it first to English.
Yeah.
The pipes and also components like ball valves, etc. It's already made in Europe. And that he, from his understanding, that for such systems they use or need special copper pipe key 65.
Yeah.
With stainless steel in
Discharge side, on the high pressure side. Yeah.
В этом случае и да, и нет. В принципе, можно использовать медную трубу КВ-65, которая имеет состав стали. Но также, как вы видите здесь, мы, допустим, используем, или в нашей учебной установке используются на высоком давлении также и стальные трубы. Просто стальные трубы, то есть не медные. I say that it could be used copper pipes with KV65, but you can also use just stainless steel pipes.
Yes, of course.
What is cheaper? But in the beginning there was a question if they can use K20 copper pipes in Russia, but I do not know K20 copper pipes.
No idea.
Not
I don't think it's from the refrigeration. Говорят, что вопрос был относительно трубы К20, но нам, честно говоря, не знакома такая маркировка. Возможно, не знаю, ну, в Европе это в холодильном бизнесе это не применяется.
Or maybe it's something totally new that we don't know.
Да, или, возможно, это что-то новое, что нам неизвестно.
But they only have to check if the K20 also is able to work
Handle
with
the
the pressure
handle-
from 100, 140 or yes, 140 bar.
No, once again.
Yeah,
You say that what we have to use is just to the pipe should take this pressure.
absolutely. They have to be sure that the pressure in the system, the design pressure of the system on the high pressure side is able to work with this copper.
Yeah,
Okay,
but that's
okay.
normal. A supplier always gives you a document for what it is possible to.
Еще раз вопрос относительно трубы. В принципе, трубу можно использовать, конечно, разную. Главное, чтобы она была чистая и все-таки приспособленная для работы в холодильных системах. Но самое главное, чтобы она выдерживала, конечно же, допускные давления. Вот, то есть, ну, здесь как бы такое, но K20 нам пока было неизвестно. Du kannst den zweiten von oben löschen, weil ich habe das von zweiten angefangen. Ja, den da. One more question from Ildar Hatipov. The question is, if we make the next seminar, can we make the real selection of the CO2 compressor or CO2 system? Is it possible, or it should be this separate seminar? Вопрос от Ильдара. Можем ли в следующем семинаре сделать реальную подборку компрессора или CO2 системы?
This is something where we should have a special seminar.
Okay.
Because it's the best if we have, before we start the seminar, we should choose one application or maybe two or three, two or three ideas of the customers, what they like to have discussed, what they like to have selected. And I think it's the best for that. We can make a short, let's say 1 hour, 1.5 hour
online meeting.
online seminar.
Yeah, just a Teams meeting.
Yes, or a Teams meeting, yes. And then we can select from our side the compressors. And I don't know how you could also make a part. That's a good idea. How we can do that, because of course we will have in the future next steps. We are collecting ideas for the upcoming seminars. That's a good thing, I think, that we can do in the future.
Ильдар и коллеги, то есть, в принципе, в разрезе данного семинара это будет сложно, потому что, наверное, это будет слишком растянуто по времени, но коллеги предлагают, что в будущем мы также сможем рассмотреть эту опцию, если будут запросы и определенные как бы задачи, может быть, тогда можно будет онлайн рассматривать на семинаре, то есть можно будет создать часовую или там, полуторачасовую онлайн встречу, скажем так, и подобрать на примере, может быть, в более маленькой группе, потому что сегодня, допустим, на семинаре присутствовало около 70 человек. Наверное, в такой большой группе это сложно, вот, но, может быть, будем разбивать на маленькие группы и практиковать вот именно подбор компрессора. У нас есть две программы подбора. Это одна программа, которая я там высылал ссылку на своем канале в Telegram. Это обычная программа подбора одного компрессора, но у нас также есть программа подбора всей системы, то есть бустерной системы, и в данный момент она только на английском, но мы также планируем перевести ее на другие языки. То есть я думаю, что это в следующие пару месяцев это произойдет. Так что, если будут такие запросы, пишите нам просто по имейлу, и мы сможем идти дальше.
Genau. E-Mail schicken, vielleicht an dich oder wer von deiner Seite. For the guys from his side, just send him an email. For the other guys on our side who want it in English, maybe we can make a separation, also one in another
I think for the invitation for this webinar, they got an email address, something from marketing, I think, something.
Yes, but I think the most of you...
После семинара вы получите автоматическое письмо с отдела маркетинга, и там, скорее всего, будут контакты, как с нами можно связаться, и вы тогда сможете любые вопросы и запросы, скажем так, прислать напрямую нам.
Yeah, Leute, die Interesse, people who will connect this. I think that's a great idea that we can do, of course. A Teams meeting. We don't have to do it here because we will just do a calculation then. And yeah, we will do that. Great.
Next question. what is the pressure, what we need to for the test the system. If you install the system and you have the put some pressure to be sure that everything is okay.
Yeah, that's a good question.
Mhm.
That's a good question. Of course, if you have the subcritical circuit with, like we have 30 bar safety valve outside,
Yeah.
you shouldn't put in this circuit a higher pressure than the safety valve. Yeah.
Mhm.
And you should close, of course, or if it's possible, the valves to the other step, to the transcritical step. Then test your subcritical, let's say with 30, 40 bars. So how not reach the
Maximum
limit of the
of
safety valve.
Yeah,
Yeah.
absolutely. That's
Stay a bit under.
Mhm.
Test it. Also, like you know it, leave it for 1-2 days the pressure. Then you can see if you have a loss of pressure and so on.
But the
And-
pressure level should be not higher than the safety valve.
For this
for
circuit,
the,
yes.
for this
For the
several circuit.
In the
Absolutely.
transcritical, of course, if you want to test, what do we have? We have 90 bar. Then you can test 90 bar,
No, not 90.
80.
89.
88 or 89, of course, not 90. Yes.
Я прочту еще раз на русском. Вопрос был, какое давление требуется для опрессовки таких систем, каких систем? Это был вопрос, да? Для того, чтобы опрессовать, то есть так как у нас, как правило, всегда будет две ступени, есть, ну, на сегодняшний день уже, наверное, каскадных установок на CO2 практически не производится, в основном используют бустер, да, поэтому необходимо отсечь сторону высокого давления, то есть бустерную, и сначала протестировать субкритическую систему. То есть если у вас ваши подрывные клапаны стоят, там, установка на 30-35 атмосфер, тогда, конечно, это прессовка должна быть ниже этого показателя, иначе он сработает, тогда вам необходимо будет заменить вентиль. И такая же самая ситуация со ступенью высокого давления, то есть там, где у нас до 90, в нашем случае мы создали систему на 90 бар, поэтому здесь, конечно, нужно опрессовывать с давлением не выше 89 атмосфер, иначе, как бы, опять же, сработает подрывной клапан и уйдет газ, и необходимо будет заново. Ну, а вся остальная процедура, она, в принципе, как и в стандартной системе, это накачали, подождали, посмотрели.
One thing,
Okay.
never forget that a safety valve, if it's once open, you never know if it will close again 100%.
То, что я говорил, что, в принципе, если при проверке сработает подрывной клапан, то на 100% вы никогда не можете быть уверены, что он на 100% опять закроет и не будет травить. Есть разные производители данного оборудования, и где-то лучше качество, где-то хуже, да. I told already that if it's blows, you have to change it. Поэтому лучше как бы не доводить до того, чтобы он сбрасывал, иначе действительно придется заменить, скорее всего.
Okay, so now we have another question.
Какие аналоги масла вы допускаете? Which oil types give you free to use in the system?
If you look at in our VIP, then you see always the oil type that we fill in during the production here.
Mhm.
That's our new BOCK loop oil. The VIP I showed before.
Okay.
There you see
Okay.
the E85 or whatever. I don't have the list in the head, but it's just easy with the documents of the compressor. You see it. If you have a special wish for oil,
Mhm.
talk with us before.
Mhm.
And then we can see if we can
It means
put
we don't have such a list where we say, okay, these types of oil we can use.
Yes, but I just don't have it here now.
No, but, as I know, we don't have, and we have to use it request by request or answer to request.
Okay, if it's a special, yes, sorry. If it's a special oil, yes, then we have to do it on request.
Относительно масла, как Михаил говорит, что он до этого показывал программу VOP, где, в принципе, есть вся техническая информация о том, какое масло заполнено, залито с производства непосредственно в той или иной модели компрессора. Конечно, там для субкритических это будет одна вязкость, для транскритических будет немножко другая вязкость, потому что зависит от температуры и так далее. Если у вас есть запросы по каким-то маслам, которые вы хотели бы заправить в систему, тогда здесь, конечно, лучше в частном порядке обращаться к нам, и чтобы мы проверили технические данные этого масла, и тогда мы можем сказать, что допускаем мы его к работе или нет. Но мы, конечно же, всегда рекомендуем, чтобы работа компрессора была гарантирована, да, системой. Мы рекомендуем заливать оригинальное масло BOCK.
Okay. Du kannst die ersten 3 kannst schon löschen. Следующий вопрос от Максима, также Давыдова. Датчик CO2. Обязательно ли условия для холодильных установок малой мощности, точнее для компрессорных отделений?
Я думаю, что это все-таки больше зависит от страны, от регулярий. The CO2 sensors, is it really a must for the machinery room, also for the small capacity rooms? I mean,
If it's
small
outside,
small
it's no
capacity
problem.
systems. I mean,
But if you're in such a room,
yeah, but
It
if you have just one 5 kilowatt capacity,
yes, if the room is big enough,
It depends of the room volume.
there is a calculation for this.
but this is the German rules, let's say, or normatives.
European, we have meanwhile,
European.
yes, this European norm. But if it's only, like I said, a small one, and you have a big, huge machine room, it's not necessary.
Я думаю, что я правильно понял вопрос. Речь идет о датчиках, которые устанавливаются непосредственно в помещении для анализа концентрации СО2, если происходит утечка. Как коллеги сказали, я переведу. В принципе, все зависит от размера установки и от размера самого помещения. В Европе есть определенные нормы в зависимости от объема помещения, какой объем ресивера или там содержание СО2 в этой системе. От этого исходит, и тогда применяется либо необходимая установка этих датчиков, либо ее можно избежать. Если вы, конечно, устанавливаете машинное отделение или там, ЦХМ, то есть ваше стоит за пределами помещения, тогда, в принципе, в этом нет необходимости. Я думаю, что я ответил на вопрос. Die ersten 2 kann ich auch löschen.
Hört ja nicht auf.
В случае использования труб из нержавеющей стали, каким способом лучше снять трубы? Это не сварка, стык, это муфта и пайка, или еще есть какой-то способ?
Translate it first in English.
Yeah, the question is if we use the stainless steel pipes, what is the best way for the connection? It's like you can move use like a muft, or you can make a soldering, etc. What is the best way, let's say?
You can soldering. Here you see the soldering part, but you can also use cutting rings. We have for our compressors, you can order the valves for soldering or with cutting rings, for example. You can
Some
choose.
benefits, some points, what could be?
Well, yeah, I mean, if you're soldering, it takes a bit longer. You know, for such small parts, I would always take these cutting ring connections.
It's easier on the end.
It's easier to handle, but of course,
But soldering is maybe more
safety.
stronger.
Yeah, more safety. It's possible both.
Okay.
It depends. I would say your personal,
Absolutely.
how you say,
Behavior, but how you can work with or
What can you work with?
Erfahrung,
Absolutely.
experience.
your personal experience. Yes. If you are safe with this, okay. But if you say, I like more this, then soldering.
Ну, как бы такой одной рекомендации нет. Как коллеги говорят, что мы используем и то, и другое. У нас как опция для компрессоров предлагаем вентиль на нагнетание всасывания как под сварку, так и под подключение, я не знаю, как правильно перевести на русский, с таким кольцом зажимным, скажем так, да. Здесь установки используются как пайка или как сварка, так и эти соединения на резьбовые, скажем, на зажимном кольце. Поэтому здесь уже, наверное, больше зависит от того, какой у вас личный опыт в этом есть, на что, не знаю, что ближе к сердцу, наверное, вот так.
Yes, and always think before you order the compressor, please, what you will use, because then you can choose between the soldering valve or the valve with the cutting ring. Yes, and then we will mount this one on the compressor and then send it out.
Как я говорил, что, в принципе, у нас есть две опции. Или вы можете заказать компрессор с такими вентилями, или под сварку, или с вентилями под зажимное кольцо. Okay, next question. Do we have some limits of the frequency limit of the compressor? Maybe I can answer this question. If you mean the range of frequency, of course we have. Yeah, it's like each compressor. But if you will check our technical data, you will see that BOCK compressors have a very high or higher, or the range of the frequency is higher as from our competitors. If you mean it's on the time base, how long you can use it with low frequency, it's completely different question. Here it's very dependent on the operating point, evaporating temperature, condensing temperature, etc. Я еще раз повторю по-русски, что если мы говорим о том, какой лимит частоты вращения, то, конечно же, он есть, зависит или влияет это, или ограничением является, скажем так, ограничением является то, что при низкой частоте вращения поток или количество всасываемого газа, оно уменьшается. Поэтому есть какое-то минимальное ограничение, чтобы не перегрелся двигатель, так как мы охлаждаем электродвигатель с помощью газа на всасывании. Но если вы сравните технические данные, то вот do they see it? Yeah? Okay. Если вы сейчас видите слайд, на слайде видно, что линейка или частота вращения, которую мы используем, это от 20 до 70 Гц. То есть на самом деле, если вы сравните с другими производителями, у BOCK самый широкий диапазон линейки частоты вращения, в которой можно регулировать. То есть если у кого-то она заканчивается на 30 Гц, то мы опускаемся ниже до 20 Гц. За счет чего добиваемся мы, опять же, этого? Потому что здесь то первое, что я сказал, это охлаждение электродвигателя всасываемым газом, а второй момент – это смазка движущихся деталей внутри компрессора. И так как абсолютно все компрессоры BOCK оснащены масляным насосом и системой смазки, то есть мы подаем масло непосредственно в те узлы, где движущиеся узлы, где детали трутся, и поэтому нам для компрессора BOCK не страшно вот эта низкая частота вращения, что из этого не хватит, например, смазки.
From my side, two small things,
Yeah.
Two little things that you should think of. We have competitors, they say we can go over 80 Hertz. First of all, if you go over 70 Hertz, you will have a massive oil throw. And second is that a lot of applications that I know from competitors, they, even if they can go up over 80, they reduce them mostly to 70, 75. So it's much important to have a more, to come down for the part load, yes, than to have these high frequencies, which nobody or not many people are driving anyway.
Okay.
You know what I mean?
Михаил говорит, что есть, или иногда производители предлагают, что можно поднимать частоту там до 80 Гц и так далее, но, как правило, только в теории, потому что когда непосредственно подбираешь компрессор в той рабочей точке, то, как правило, электромотор не позволяет работы в этих пределах. Плюс, конечно же, быстрее изнашивается клапанная доска и все остальные элементы. Но и в практике, в принципе, более важно нижний предел частоты вращения, потому что в этом моменте, если у вас ЦХМ на 3-4 компрессора, да, тогда вам, в принципе, более важно, чтобы компрессор работал на более низких частотах, чтобы ступени регулирования были как можно мельче, и из этого будет происходить более плавное регулирование.
Okay.
Если из ограничения, ну, я думаю, что, наверное, на этот вопрос я ответил, да.
Ну, Ильдар, еще раз, максимальное, минимальное значение пределов применения частотника, в принципе, для каждого компрессора оно, или для каждой линейки оно бывает разное, но в среднем вот у нас 4-6-цилиндровые компрессоры транскритические, мы допускаем регулирование от 20 до 70 Гц. Next question. Ruslan Timonov has a question. He says that he read some information that if you start with the system, if you make a start, that you should 3 times to bring the vacuum and then to fill it with azote and then again. And the question is, it's really process what we are using in Europe, that we do it 3 times, or we do it just 1 time and it's enough?
Well, I would say it depends on how big is the application. Is it a big supermarket with very long piping? You know, sometimes in a supermarket you have kilometers of pipings. How good have you worked? You know, how clean have you worked?
Okay.
I would say 3 times. Ooh, okay, to be honest. Yanni, you're also a practical guy. How often have you cut the pressure?
Until you reach maximum vacuum from the vacuum pump, maybe 1.5 bars.
It means if you reach it from the
Yes,
first
but
time, it's
they
enough.
asking, they are doing 3 times. They want to do
3
it.
circles. Or...
That's a bit much. I would say 3 times. It's better if you leave the vacuum pump overnight for a long time working, you know. Then maybe 1 or maximum 2 times. It's okay.
Ну вот ребята, они, в принципе, практические техники работали и работают здесь в Германии на живых проектах. Говорят, что все, конечно, во-первых, зависит от длины трассы, от разветвленности и так далее. Если там здоровенный супермаркет, тогда это, конечно, может быть и необходимо. Опять же вопрос, насколько вы уверены в том, что монтаж будет сделан хорошо, правильно, качественно, без там мусора, влаги лишней и так далее. Но в Европе, так чтобы это действительно выдерживать, что необходимо минимум 3 раза, нет. Самое главное, чтобы сделать вакуум, и чтобы установка держала вакуум. Если, может быть, у вас слишком разветвленная система, тогда, может быть, необходимо делать это какими-то отдельными кусками. Ну, вопрос скорее нет. Du kannst dann die 1, 2, 3, 4 löschen. Jetzt sind wir hier. Камол, здравствуйте. Приятно, что вы посещаете наш семинар. Большой привет в Узбекистан. Вопрос. It's possible to share the PND for the standard low temperature? You can read it.
Yes. Customers who send us their PID Fließbild, meint oder?
Ja, aber then he said, I mean real drawing. Real drawing is schema of pipes, etc. I don't think that we have such.
We don't have such.
Something we don't have. Sometimes we get from a customer, but we handle that really with, they don't like it if to give it out. So we are very fair with that. We cannot share that.
Что у нас есть, это только принципиальная схема, и опять же, ребята говорят, что как бы это не наша собственность личная, да, это собственность наших клиентов, то есть они разрешают нам показывать, но мы не имеем права делиться такой информацией. А что касаемо реальной схемы по трубопроводам, на самом деле у нас такой ее в принципе и нету, потому как, допустим, мы сами не проектировали, мы дали какое-то техническое задание на установку, и компания-производитель, она уже как бы по этим техническим заданиям, по своим стандартам создала установку и поставила те компоненты, которые необходимы.
But we have no problem with our system here. We have a look.
Okay. Ну вот Михаил говорит, чем мы можем поделиться, это мы можем поделиться схемой данной системы, как бы это наша собственность, и вроде бы есть вот диаграмма, этим материалом мы можем поделиться. Поэтому если будет желание, потребность, тогда пишите мне лично или ребятам, и можем поделиться этим вопросом. Окей. Вопрос следующий. Какой протокол запуска компрессора при пуске нужно включать его на 50 Гц и только потом перейти на определенные частоты? Или можно запускать компрессор с минимальной частотой, чтобы не повлиять на ресурс компрессора? The question is, if we start the system, should we start immediately, and we use the frequency inverter, yeah? Should we start immediately with 50 Hz, or we can start with 20 and go up?
Yes.
Yeah.
Just
Mhm.
the normal, the controller will choose his frequency that's needed for the beginning.
Okay. Okay.
So we don't put it on 50.
No,
but
it was the question from the using of compressor. I mean, for the compressor, it doesn't matter.
No, for the compressor doesn't matter. But remember, we always have here only one of each. But in a big system, of course, you
can
will
use
have
for each one.
3, 4 of them, 2 parallel compressor. Only the first is always frequency drive. The others come always 50 Hertz, no problem. Part winding we have a part winding on them, so they come even. Yes.
Well, if you don't use frequency converter, you use part winding system, it means the 50-50. Относительно вопроса, как запускаемся, здесь, в принципе, зависит от регулировки системы. Для компрессора это значение не имеет. В принципе, чем ниже он стартует, тем, наверное, лучше. Опять же, лучше для пусковых токов, меньше перегревается двигатель и так далее. Но здесь уже просто вопрос вашей регулировки. Что ваш контроллер говорит системе, какая мощность необходима и так далее. По-хорошему, в принципе, запускается первый компрессор, который работает с частотником, начинает там с 20 или там с минимальной частоты вращения, поднимается наверх, да, как только он достигает ее, срабатывает там команда по времени, например, если необходима дополнительная мощность, включается второй компрессор на полную мощность, да, при 50 Гц, и тогда первый компрессор опускается вниз, если нет необходимости в работе двух компрессоров на полную мощность. Поэтому в этом случае даже рекомендовано запускать компрессор на более низкой частоте, чтобы не было излишних пусковых токов. Надеюсь, ответил на вопрос. What is the limit of the frequency what we recommend? I said before that actually we recommend start with minimal frequency if it's possible, and then go up, and then you switch on second or third compressor if needed, and you go down вниз. То есть, как я уже говорил, то есть нет какой-то рекомендации именно по частоте, с которой начать. Поэтому здесь контроллер или частотник, он просто начнет с той частоты, на минимальной частоты, на которую он установлен. Если там это 25 Гц или 30 Гц, в зависимости от компрессора, в зависимости от установки и так далее. Поэтому просто с минимальной, скажем так. С минимально допустимой для этого применения. Kamal, is it allowed to use tube benders instead of elbows in liquid or gas lines? Tube benders instead of elbows. Tube benders. I think he means if we can use fittings instead of elbows. I mean,
if you make that by your own, this is made with an elbow.
Yes.
Yes.
But can we use fittings as well? It's
yes, you have K65 fittings. You have to use the K65 fittings.
Здесь опять же вопрос в том, что фитинги можно использовать, но они должны быть, как правило, на КВ-65, если вы используете медную трубу. Ну и опять же должны выдерживать те давления, смотря где они установлены, да, то есть на низкой ступени или на высокой ступени.
You smaller the pipe, you just.
Ну да, чем меньше диаметр трубогиб вместо отвода. Ну да, я думаю, что я правильно понял вопрос. То есть на маленьких диаметрах, конечно, удобнее, наверное, использовать трубогиб. На больших диаметрах, если не получается, используйте фитинги. Ну, в принципе, от себя могу сказать, то есть из своего опыта, конечно же, гнутая труба, она всегда будет более прочная, чем спаянная труба. Поэтому здесь, где возможно, используйте трубогиб, где нет, используйте фитинги. Окей. 1, 2, 3, 4. Ты можешь die ersten 5 kannst löschen. Максим Давыдов, чем отличается... Секундочку. Фильтра, кроме корпуса, на линии низкого давления и на жидкостной линии относительно... Чем отличается фильтра, кроме корпуса, на линии низкого давления и на жидкостной линии относительно обычных холодильных систем? Но фильтра... Окей, я переведу сначала. What is the difference of the filter trougheners, of the filter on the low stage and high stage on the liquid line, etc., comparison to the standard systems? I would say it's, first of all, it's pressure, allow maximum working pressure.
Yes, yes.
And
then you
the
have
second point is the filter inside, the filter
Yeah.
element.
As I saw outside, yes, the suction filters are all different than the normal liquid filters that you have in the liquid line. And you have to take care of the pressure. Is it released for the high pressure? And that's all. Yeah.
Den habe ich rausgeholt. Den bringen die dann raus. Wo sind die auch? Das sind die für die Saugleitung.
This is, for example, this is for the suction side. For the suction side, it's a different one from the material than the one. We have everything here. Then the one, this one is in the liquid side. The filter dryer, as we know, the filter dryer. Yes, this is this stone thing, I don't know. And here, this is the suction side. It's only, how you say it, Stoff.
Material. Some material
smooth,
like
smooth,
textile
material. Yes, this is suction side.
Ну, если сравнивать, то чем отличается на низкой и жидкостной линии, да, то есть на стороне всасывания, как правило, он идет с сеткой, плюс есть какой-то текстильный фильтр, скажем, да, а на линии жидкостной, конечно, это уже больше фильтр-осушитель, который выводит влагу из системы, насколько это возможно. То есть тут совсем другой материал, он больше похож на камень, да, который должен абсорбировать влагу из СО2. В чем они в общем отличаются? Конечно же, опять же, по давлению, да, то есть максимальному рабочему давлению, по размерам. Вот. Ну и самая принципиальная особенность, конечно же, это внутренняя вставка.
Maybe we can show it, you can see it better here. This is like, you know, and this is suction side.
На линии всасывания, а первый это был на жидкостную систему.
Suction side is more important that we don't want dirt inside the compressor.
Ну да, фильтр на всасывании служит для того, чтобы не допустить попадания каких-то там частиц или грязи в компрессор, а на жидкостной линии, как я уже говорил, что как бы служит тем, чтобы абсорбировать влагу, скажем так, из системы или из холодильного агента, если я правильно выразился. Next question is, what is the recommended sequence of capacity control? We should reach 100% at nominal 50 Hertz and then increase same as in screw, or we may increase frequency at 50% capacity.
Capacity control. At the moment, we don't have the digital capacity regulation.
For the CO2, we have it for the standard compressors,
We have it for the
but
standard.
we don't have it for the CO2.
Yes. So at the moment, I can't give you an answer to that, but it will come. I think what
Soon.
they say
Soon.
soon. Let's say soon. Yes, soon. It will come soon.
Камол, относительно, если мы правильно поняли вопрос, для CO2 компрессоров у нас в данный момент мы не предлагаем отжим клапанов. То есть такой регулировки мы в данный момент не предлагаем. Для стандартных компрессоров она есть, электронная или дигитальная, но, поняли, но не для CO2. Должно появиться в ближайшем времени, но как бы точную дату там сказать пока невозможно. Возможно, в следующие несколько месяцев. Окей. Денис, еще один вопрос от Дениса. есть частоты, которые приводят к разрушению компрессора из-за резонанса, какой диапазон частот для компрессоров BOCK. It means that there are some frequencies which could bring to the damage of compressors, and what is this frequencies of the BOCK compressors. From my knowledge, it's not dependent on the compressor, it's mainly dependent on the system. Sometimes for the same part of compressor, maybe you can have some strong vibration at 45 Hertz, like example. For other system, it maybe will be 47 or 37. In this case, you just go to the setting points of the frequency inverter and took out this frequency range and say, okay, if we reach 35, we have to jump to 40, for example, or to 38, right?
Yeah.
But
here, it's in this case, we have no
it's completely
cut out. It's completely open, and in this application, we don't have problems. Like you said, it's also a bit, it's not only the compressor always, it can be, but it's most of the time.
Operating point and also construction of the system.
Yes.
Еще раз к вопросу, в каких частотах может быть там излишний резонанс, и чтобы его избежать. Нет такого показателя, то есть мы его измерить или выявить абсолютно не можем, потому что это зависит не только от самого компрессора, это зачастую зависит от рабочей точки, в которой компрессор работает, и, конечно же, еще от конструкции самой системы. Из опыта это происходит где-то там между 36-37 Гц и так далее, но в этом случае, в принципе, для любого компрессора, для любой системы идете в настройки частотника, если он это позволяет, он должен, в принципе, это позволять, и просто перепрыгиваете вот этот там момент 37, или если он там с 36 на 37 вибрирует слишком, да, вы перепрыгиваете с 35, например, перепрыгиваете сразу на 38, и тогда, в принципе, проблема этим решается. Оно не приведет, возможно, к поломке компрессора, но это будет излишние вибрации, которые могут привести, может быть, к поломке системы или там какой-то трещины в трубопроводе или еще что-то. Вот, пока так. И в данной системе Михаил говорит, что мы, в принципе, не перепрыгиваем, то есть здесь компрессоры работают на весь диапазон регулирования, то есть с 20 до 70 поднимаются, опускаются, потому что, в принципе, если вы видели, на самом деле сама рама поставлена достаточно жестко, и тут хватает веса для того, чтобы, наверное, избежать те моменты, или, может быть, нет тех таких излишних нагрузок. Надеюсь, что ответил. One question from Ruslan. The point is, it's interesting once more to understand how we drive or how we keep the pressure in the receiver, in the middle pressure station. Yeah. When we switch on the parallel compressor, and at what point we switch it off.
Oh yeah. Oh no, unfortunately, Knut is not here anymore.
Okay.
He's driving back to Berlin, and he just went half an hour ago. That would be a Danfoss question, because yes, you know, it is depending, of course, of the pressure of the receiver. If we get the flash gas in the receiver, if the pressure is getting higher, then the valves, the special valves are opening. But sorry, that's now should have asked before, as Knut was here, so we could explain it.
Михаил говорит, что это больше, конечно, вопрос был бы к нашему коллеге от компании Danfoss, но он, к сожалению, уже уехал, так как ему еще необходимо доехать до Берлина. But to understand the logical, I mean, if you have too much flash gas in the receiver, we have to switch on the parallel compressor.
Yes, so
this is the main reason. That's
yes, so in that.
Yeah. Ну, в принципе, как по логике своей, то есть как только флеш-газ или количество флеш-газа в ресивере становится слишком большим, в этот момент включается параллельный компрессор, чтобы его откачать. Я не совсем знаю, что такое FGB-клапан. Яни? What is FGB valve? Do you know it? Flash gas bypass. Окей. Flash gas bypass. В какой момент включается параллельный компрессор? Does it work together, flash gas bypass together with parallel compressor?
Can you switch on the?
This here?
Yes. CTR, the PV, this valve changes. Yeah. Ups, just a second. Das hätte sie vorher fragen sollen. Das wäre besser. This is the PV switch valve. It changes when the pressure here inside is getting high. Yeah, then we choose between parallel compression or if we go normal in the suction side of the empty compressor.
То есть зависит от давления в ресивере, да, и в тот момент, какая есть установка, если он слишком высокий, тогда выбирается между параллельным компрессором или подается на всасывание в обычный или в верхнюю ступень бустерный компрессор. But do you know what is the pressure setting or when we have to go for this?
This is a question for Danfoss. No,
Okay.
Here at the moment, I don't know. Frank is also not here.
Okay.
I'm sorry.
Не могу, к сожалению, ответить на этот вопрос, потому что виноватые в этом люди уже не здесь. Может быть, если есть желание, напишите нам на почту, и мы попробуем осветить это дело.
Okay.
Пока больше вопросов нет. В любом случае, как мы говорили до этого, вы можете обращаться к нам напрямую. Может быть, это будет, конечно, не в прямом эфире, но мы постараемся ответить на те вопросы, которые возникнут в будущем или в текущем времени. Огромное спасибо за то, что приняли участие. На самом деле, очень много сегодня было вопросов. Надеюсь, что на все мы смогли ответить. Если нет, задавайте еще раз или, как я уже сказал до этого, пишите нам на почту.
Questions are gone so far? Okay.
Maxim said, thank you, colleagues.
Okay. So thank you also. Yeah, guys, so we are at the finishing. Thank you for participating here. As I said today, I hope someday we will have a training on displays again with 2 days. You're also invited if you like to come here. For these trainings, we have also HC-LG training. That's much shorter. It's only 1 hour approximately, but I think you also do that in Russian. I don't know.
LG, no, but yeah.
Yes. And yes, maybe see you there also one day or here on site. Would be great, of course. So from our side, thank you very much. Have a good time. Stay healthy. That's also important.
Take a distance.
And yes, have a good time. Thank you very much.
Еще раз большое спасибо. Будем рады вашим отзывам, вопросам. Михаил сказал, что скоро будет проводить семинары по линейке LG. Это наша новая линейка, которую мы выпустили в прошлом году, Low GVP, но, насколько я знаю, на сегодняшний день на постсоветском пространстве, если можно так сказать, это пока еще не настолько интересно, как CO2, то есть это линейка, которую непосредственно мы разработали для новых холодильных агентов, как R744 и так далее. Я думаю, что, скорее всего, здесь будет скачок больше с 404 сразу на CO2, поэтому мы будем стараться со своей стороны давать как можно больше контента на русском языке, на других языках, польский, французский, итальянский, как бы мы над этим работаем. Поэтому насколько нас хватит, настолько мы будем расширять свои горизонты. Еще раз огромное спасибо. Спасибо за участие и пишите, звоните, будем рады.
Okay. Thank you. Yanni will show welcome.
Коллега за
Bye-bye,
кадром. Чао.
Ciao.
Ciao. Bye bye.